everyone, my name is Nikita Gaikwad from Anna Sahib Dange College of Engineering and Technology. So in this video we are going to talk about the operational amplifier. What is an operational amplifier? So as its name suggests, this op-amp is basically amplifier and the basic job of an amplifier is to amplify the input signal. Let us understand why it is known as an operational amplifier. So in early days, when digital computers were not involved, at that time the different mathematical functions like addition, subtraction, integration and differentiation were performed using this, and that is why this amplifier is known as operational amplifier. Now let's move on the next point. These are different characteristics of ideal op-amp. Infinite open loop gain, infinite input impedance, zero input offset voltage, infinite output voltage range, infinite bandwidth, zero output impedance, zero noise, infinite common mode rejection ratio, infinite power supply rejection ratio. Now we discuss in detail. So the ideal op-amp should have this input impedance Ri that is equal to infinity, so that whatever input that is being applied between the input terminal will directly get applied to the op-amp. See this circuit diagram. The output impedance of this op-amp should be equal to 0. That means whenever we are applying the output load to this op-amp, then the output voltage should directly come across this output load. Now bandwidth. Bandwidth of ideal op-amp is infinity. It means it should support all the frequencies start from 0 Hz to infinity. Slew rate. The slew rate is basically how fast the op-amp is able to reach its final value. This slew rate is defined in the unit of volt per microsecond. Next, common mode rejection ratio. If we are applying the same input voltage to this V1 and V2, then the difference between these two voltages will be equal to 0, and at the output we should get 0 volt. Likewise, when we are applying different input voltage V1 and V2 to this op-amp, then at the output the difference between these two voltage will be get amplified by certain amplifier gain. So this common mode rejection ratio basically defines how well the op-amp is able to reject the common input voltages that are being applied to both its input terminal, and how well it is able to amplify the difference between the two voltages. So for ideal op-amp, the value of this common mode rejection ratio should be equal to infinity. But a practical op-amp, they used to have an infinite input as well as output. This is the block diagram of op-amp. First stage is input stage. It must provide a very high input impedance to prevent loading of the input stage. So for an ideal one, it is infinity. It must have two different inputs. Any common mode signal such a noise signal are removed by using a differential input. If will increases the bandwidth so that op-amp can be used for a very low frequency and a high frequency signal. Second block is intermediate stage. This is known as a gain stage. This will provide additional voltage gain to achieve a large overall gain. Next stage is buffer and level shifter. Buffer is usually with a higher input impedance and low output impedance, and unity gain that will prevent loading when it is connected between intermediate stage and output stage. Last stage is output stage. Requirement of an output stage. First, output impedance must be low. Second, output DC voltage swing must be large. So now if you see this circuit symbol of the op-amp, so it consists of a two input and one output. So most of the amplifier consists of a two power supplies, the positive and negative power supply. But there are many op-amp IC which runs on the single power supply. Now in this operational amplifier, the input terminal which is marked by a positive sign is known as a non-inverting input terminal, and another input terminal which is marked by this negative sign, this is known as the inverting input terminal. Let's say V1 and V2 are the input signal which is being applied to this operational amplifier, and the gain of this operational amplifier is A. Then the output will be equal to A times the V1 minus V2. See the pin diagram of IC741 with the 8 pins. Out of those 8 pins, only 7 pins are used. Out of those 7 pins, 4 pins are for input and 1 for output. Hence, name of this IC is 741. Pin number 6 is for output. This IC needs two power supplies as a positive and negative, which is given at a pin number 7, that is positive, and the pin number 4, that is negative. Between pin number 1 and 5, an offset resistor is connected. Pin number 2 is called as an inverting terminal, and pin number 3 is called as a non-inverting terminal. Now, these are the types of amplifier. First, voltage control, voltage source. Second, voltage control, current source. Third, current control, current source. Fourth, current control, voltage source. Now we see the advantages. Small size, low cost, less weight, low supply voltages, low power consumption, highly reliable, matched device, fast speed. Disadvantages. Most op-amp are designed for a lower power operation. Second, for a high output is designed, then the op-amp specifically designed for that purpose must be seen. Third, most commercial op-amp shuts off when the load resistance is below a specific level. Now we see the application of op-amp. First, audio amplifier. Second, low dropout regulators. Third, active filter. Fourth, medical sensor interfaces. Fifth, baseband receivers. Sixth, analog to digital converters. 7, oscillators. 8, signal generator. That is the end of my presentation. I hope you enjoyed. Thank you.